Hi viewers, my name is Tipo Short Game. I welcome you to the Chem is Try channel. Today we are continuing with our redox reactions, and today we are going to see how we construct redox reactions as well as perform calculations based on the redox reactions. So we want to construct redox reaction, and then we are also going to perform calculations based on the redox reactions that we would have constructed. And for this task, we are going to look at a past exam paper, a SimSec paper, which we are going to answer in order to achieve those two objectives. This is a November 2014 SimSec paper 1, and I'm going to look at question number 1, section C, the whole of it. And the question reads, a 1,50 gram sample. The important information, let's extract that. 1,50 grams of anhydrous iron 2-ethane dioxide, FeC2O4. And this was dissolved in 100 cubic centimeters of water. And then of that sample, 25 cubic centimeters was taken, and it required 15 cubic centimeters of potassium permanganate for complete reaction. So the first part, we must use the given half equations to write the overall equation for the oxidation of iron 2-ethane dioxide and potassium permanganate. So the half equations we are given there, and they are written as reduction potentials. They are written as reduction potentials. We are going to look at this in the next section when we look at electrode potentials. So CO2 plus 2 reversible C2O4 2 minus. This is our ethane dioxide ion, and we also have Fe 3 plus electron reversible Fe2 plus, and then the permanganate MnO4 minus. Let's use this one to show how we can construct that half equation if you were not given. Okay, so this one normally undergoes reduction because it's an oxidizing agent. This is an oxidizing agent, and it normally operates under acidic conditions. So I know it needs acidic conditions, and it's an oxidizing agent, and it's normally reduced to Mn2 plus water. So let's use this one to construct this half equation from nowhere. Suppose we're not given. Okay, so in this particular case, let's balance the half equation in terms of atoms, and we must also check to see if the equation is balanced in terms of charges. Okay, so we have 4 oxygens, so I need 4 moles of water, so that I end up with 4 oxygens. But in the process, I end up with 8 protons, so I ate 8 there. And then for the electrons, I have 2 possible ways of determining how many electrons we need. I can use balancing of charges. Here we have an overall of 2 plus, so it also means here we must end up with a 2 plus. There is a negative already, 8 positives, so we end up with plus 7. And in order to remain with plus 2, I need 5. This is one way. Or the other way, I must determine the oxidation state of manganese in the permanganate. So X plus 4 times minus 2 is equals to minus 1, because it's an ion, so the sum should add up to the charge. So X minus 8 is equals to minus 1, circa X is equals to plus 7. So I'm moving from plus 7 going to plus 2. We can construct our number line if the math is a bit difficult for us. 0, 1, 2, 3, 4, 5, 6, 7. So I'm standing at 7 and I must come to plus 2. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5 steps. 5 electrons. So these are the two ways by which you can balance the electrons. You can use the charges, or you can use the changes in the oxidation states. So from us to move from plus 7 to plus 2, we need to gain 5 electrons. So let's check the charges. They are now balanced because negatives, and now you have 6 plus 8, which will give us plus 2, and here we have plus 2. So this is now balanced in terms of atoms as well as in terms of charge. And I think this is the one which you have. This is the half equation which you are given. This is how you determine it. And then let's see for this one. Because they are written as reduction potentials, please, you must identify the reactants which you were given. I was given iron 2 going this direction, ethane dioxide going in that direction. Don't take carbon dioxide and the iron 3 because these were not given. Okay? And for a redox reaction to occur, one must undergo reduction, the other one must undergo oxidation. Because if you consider iron 3 and carbon dioxide as your reactants, then this is a non-starter. Because all the species involved, they all require electrons. So who the hell is going to give those electrons? Okay, so please, we must mind, especially when you are given the half equations. They are given as reduction potentials. So you must reverse those who need to be reversed. So in this case, iron 2 is this side, so you have to reverse it, and the ethane dioxide you have to reverse. So the reverse reaction, which is our oxidation reaction, is now going to be C2O4 2 minus to give us 2 CO2 plus 2 electrons, and Fe2 plus going to give us Fe3 plus 1 electron. So the species which is undergoing oxidation is capable of giving us 2 plus 1, so it's giving us 3 electrons. And the one which needs to receive 1 more requires 5. So we need to balance. When you are now combining the two half equations, you must now balance them in terms of electrons. The electrons produced should be equal to the electrons consumed. So we are going to find the lowest common multiple of 5 and 3, which is 15. So how many 5s are in 15? So this one will multiply it by 3. And how many 3s are there in 15? In this whole system, we multiply it by 5. And by so doing, we end up, the first one becomes 3 MnO4 minus plus 3 times 8 gives us 24 H plus 3 times 5, 15 electrons, 3 Mn2 plus 4 times 3, 12 waters. Everything inside the brackets upon removal of brackets must be affected by the factor outside. So this one is now 5 C2O4 2 minus to give us 10 CO2 plus 10 electrons. And the other one is 5 Fe2 plus to give us 5 Fe3 plus 5 electrons. So the 10 plus 5 electrons gives us the 15 electrons which we need. And so these electrons were produced and they were consumed. We cancel those which were produced and consumed by a diagonal line. And if I have the same species as a reactant reactants as well as products, we must deal with them. But in this case, we don't have anything else. So after this, I now combine what remains in the reduction equation as reactants and that which remains in the oxidation process as reactants. I combine them and they give me the reactants. So our reactants are 3MnO4 minus plus 5 FeC2O4. I can write it like this. And this plus 24H plus. It's another reactant. Is there another reactant? There is no other reactant. So these are my reactants, and then now I put an arrow and I take the product of the reduction reaction, I combine with the products of the oxidation process. So 3Mn2 plus 12 waters plus 10 CO2 plus 5 Fe3 plus. This is the balanced equation that we have. So this is how we go about constructing our balanced equation. Now we have our balanced equation. We are now going to use it in calculations. So our task from our question, we must calculate the concentration of potassium permanganate. And please note, the potassium is left out because it is a spectator ion when we are constructing the half equations. We only use ionic equations. And in ionic equations, we exclude spectators. Spectator ions are the ones which remain chemically unchanged on both sides of the equation. So K plus remains as K plus as a reactant. It also remains as K plus as a product. So it has neither gained or lost electrons. So it did not take any part in the reaction. So it's a spectator. Now, let's now use this information so that we can achieve. So the first thing that we need to do is we must find out the information that we have. We have the mass of ion ethane dioxide, and we have the identity of our compound. Using this identity, we can calculate its relative molecular mass, and I refer to the relative molecular mass as a mister. So please, whenever I say mister, know who I'm referring to. So we can use this information, these two pieces of information, to find the number of moles of ethane dioxide which are supplied. So let's first find the mister for ethane ion 2 ethane dioxide. And to find the mister, we simply the relative atomic masses of each element present in the formula. That is how we find the mister. So iron, let's take it as 56, plus carbon is 12, and there are 2 of them, so 2 times 12, plus oxygen is 16, but there are 4 of them. So that's how we go. Those in the background, may you please quickly compute this for me and tell me my answer. 56 plus 24 plus 64 will give me how much? 144. Thank you. That's my mister. Next, I now can determine the number of moles of FeC2O4 present in the given mass by using the formula mass over molar mass, which is the mister in grams. And so this is equals to 1,50 divided by 1,44. Sorry, divided by 44. And this gives me how much goes in the 0,0,1,4,1,6. So because I want to use the value in further calculations, I'll try to leave it correct to about 4 or 5 significant figures. So 0,0104116. I think I'll leave it like that. Okay, because I need to use it in further calculations. Now I have those number of moles, and the next thing that I was told is that number of moles is present in 100 cubic centimeters. Now I have moles, I have volume. I can now calculate the concentration of the iron 2 ethane dioate solution. Therefore, concentration, I use the formula, concentration equals to moles over volume. And so, remember our volume concentration should be moles per dm cubed. So the volume, I must express it as a decimeter. So my moles is 0,010416. I divide by 100 and I multiply by 1000. This 100 over 1000 is for me to convert my volume from cubic centimeters to cubic decimeters. Please perform this calculation for me so that I get that so? Okay. This is now the concentration, and so this is moles per dm cubed. That's the concentration of my iron 2 ethane dioate. Now let's move on. That concentration, I took 25 cubic centimeters of a solution of that particular concentration, and it required 15 cubic centimeters of the permanganate. Let's now find the number of moles of iron 2 ethane dioate present in the volume which was used. So moles of FeC2O4 is equals to, I have the volume, I have the concentration. So I must make moles the subject of the formula. Therefore, moles equals to concentration times volume. This is not the formula that I use. This expression, moles of iron ethane dioate is equal to concentration times volume, and so this is concentration. We calculated it before, 0,416, and we multiply it by 25 over 8,000. Please remember to convert your volume to cubic decimeters. Those in the background, if I do this, how much do I get? 0,00260604. 26604. That's all. 0,0026004. Like that. Okay? Please don't remove it from your calculator, leave it like that. Now these are the number of moles of ethane dioate which are reacting. So we are now going to use our balanced equation to find out the number of moles of the permanganate, and they are in the ratio 3:5. Okay, so the number of moles of the permanganate or 4 minus is now going to be equals to 3/5 the number of moles of FeC2O4 according to our stoichiometric equation. Therefore, we are now going to multiply the number of moles of iron that we obtained by 3 and we divide by 5. Please perform this one. So 3/5 times 0.002604, and we get 0,624. Okay, so these are the number of moles of the permanganate. Correct to 4 significant figures. 1, 2, 3, 4. Let's remain with our level of significance. So this number of moles, please note, they are present in 15 cubic centimeters of the permanganate which was used, because the question clearly stated that 25 cubic centimeters of the iron 2 ethane dioate required 15 cubic centimeters of the permanganate for complete reaction. So this number of moles are present in 15 cubic centimeters. Now the last task, for me to calculate the concentration. Please subscribe, like and share. Now let's calculate the concentration. To calculate the concentration, we now simply want to find the number of moles of the permanganate which are present in 1 dm cubed. So moles, if these are present in 15, what about in 1000? Can they be less? So moles of MnO4 minus in 1000 cubic centimeters, this will not be definitely more. So this will be more. So we use simple proportion, 1000 over 15 times 0.001562. If I do this, those in the background, how much do I get? 0.104166. Okay. Now my final answer, I must always leave my answer. If there is nothing specified, I must leave my final answer according to 3 significant figures. Hence, the concentration of the permanganate is now going to be equals to 0.104 moles per dm cubed. Okay, so voila. That is what the is, all the is in the calculations. So please remember to subscribe to the Chemist Try channel, like and share. So chemistry is not difficult at all. All you need to do is to try.